Let's get started with this first full lesson on class hierarchy and interfaces in Java. We will begin by learning to recognize the need for subclasses and inheritance hierarchies in Java programs, using an example to help motivate key design choices. After completing this lesson, you will know how to use the proper syntax for extending existing superclasses to build an inheritance hierarchy. You will also recognize what polymorphism is and be able to write methods that override the methods inherited from a superclass. Finally, you will understand how to apply the keyword super to situations where you need to access methods from a superclass. As you've no doubt noticed, there is some new terminology to learn as well. So let's get going. To motivate our discussion of objects and classes, consider the design of a game where we have several different types of characters. Or even more accurate, you may have been asked to design the classes for the characters, and another group or groups will design the gameplay. At first look, these characters are very different, with different rules of how they move, capture, and are captured. But upon closer inspection, each of our classes may indeed have a few things in common. For example, each object will occupy a current position on the game board. They can be assigned to a team color. Each object may or may not be captured, and each object will have a certain number of lives. We could consider this the state of a character. These characters also share a common behavior, to move. We can take advantage of Java's capability to implement subclasses, superclasses, and inheritance to create a hierarchy like this one. The superclass, Angry Blue Spike, will define all of the state and behavior that our objects have in common. State and behavior unique to an object will be defined in its own class. We can picture it this way. All of the other characters in our game descend from the Angry Blue Spike class. This will be the simplest character in our game. After defining a superclass, we can begin defining subclasses. For example, Class Kobe is a subclass of the AB Spike class. Class Wingback is also a subclass of the AB Spike class. Consider what we will include in the superclass AB Spike. We may include fields such as color, captured, life, and position. Since position will be defined by both an X and Y coordinate, we will define this field as a two-element integer array. Here is what the code of our superclass AB Spike would look like. There is nothing new here. It looks just like the class files that we have learned to create in our previous modules. We might also include a constructor in this class. The constructor would set all the field variables. Here is what that code might look like. Simple mutator methods or set methods may include public methods setColor and capture, as well as private methods like setPosition and setLife. The private designator is needed for setPosition and setLife because these will be helper methods for a more complex mutator method that will actually move a character, as we'll see later. Here is the code of these mutator methods. Notice the use of the keyword this in the setColor method. Accessor methods might be included like those pictured here. To access the position of the character, we have created two methods, getX and getY. This is done to make interaction with a character easier for the user. It is simply a design decision that you may or may not employ yourself. Finally, we include a move method to move a character on the board. It uses the private methods setLife and setPosition if it has been determined that a move of this character is possible. You can also see that we return a Boolean value to the calling program, indicating whether or not the move was made. What the calling program does with that information is up to that designer. Don't forget to override the toString method and create a suitable string to display selected fields. Here is an overview of the AB Spike class to summarize. The class has 4 fields that we have labeled as private. There is a constructor for the class. and here are two of the public methods. Continuing with the class, we have the two private set methods, and then the rest of the public methods. Now let's consider how we can leverage the work we have done in the AB Spike class when creating the Ghoul class. Recall that the Ghoul class is descended from the AB Spike class. It is a child or subclass. The syntax for a subclass is shown here. We use the keyword extends, followed by the name of the superclass. In the body of the subclass, we only need to declare any additional fields or define any additional or overridden methods. The subclass will inherit much of its state and behavior from its superclass. Every Ghoul object is also an angry blue spike object, and therefore has color, captured status, life, and a position. All the public methods of the angry blue spike class can be called by a Ghoul object as well. What does it mean when we say that all of these state and behaviors are inherited by the Ghoul class? We will see in a moment that we don't need to write much code to create a Ghoul class. In this example, we will only write a constructor and override the move method. But let's take a look at all of this in a little more detail. Here is the code we might see in a client program. A Ghoul object Jim is created, and then Jim can invoke the method capture or the method move. Recall, however, that not every character moves like the angry blue spike does. We need to override the move method. The method implementation that Ghoul would inherit from the superclass AB Spike is not how a Ghoul will move. We override this method in the Ghoul class by writing an alternative implementation to be used by Ghoul objects. The Ghoul can move diagonally one space in any direction. Here is a slick way you can check that by comparing a Ghoul's current position to the proposed new position. We also have to make sure the life level is greater than 0 as well. But this is true for all characters in the game. Let's compare these conditions with what we have in the current AB Spike method. Notice that once we determine that a proposed move is legal, the act of moving is the same for both the superclass and the subclass. And if there is not sufficient life left in the character, the result is also the same. I've rearranged the conditions needed in the Ghoul class. Now we can see that the entire AB Spike move method is actually a part of the proposed Ghoul version of the move method. We can capitalize on this to minimize the amount of code we need to write. Why do we keep trying to avoid writing code? There are several good reasons, actually. For example, if you and your team spend a fair amount of time writing and testing a method or code segment in the superclass, why redevelop or even rewrite it? Just call the already tested code. Avoiding the rewrite of code also means we won't introduce errors when trying to recreate it. Finding errors when there is only one place where each function is performed makes the problem easier to find. We don't have to keep track of where all the copies of that code appear in this program. If we want to change or update code in any way, there's also only one place we would need to go to do that. And finally, it makes our code more easily readable and traceable. But back to our move method in the subclass Ghoul. We can replace some of our code with a call to the move method that has already been written in the superclass AB Spike. Here is the code we would need in our Ghoul class to override the move method in the superclass AB Spike. Notice this method must have the same name, parameter list, and return type in order to override the original method. In this implementation, we will need to call the method defined in AB Spike. To do this, we use the keyword super. If the proposed move is a legal one, then we make a call to the move method in the superclass. Recall, there the life level will be checked, and if that allows a move, the move will be accomplished and the value true returned. Otherwise, a value of false is returned. If the move is not legal, then there is no need to call the superclass method and continue checking life level. We simply return false. Writing this method in the ghoul class will override the original version written in the Angry Blue Spike superclass. The example we just looked at, writing the move method for the ghoul class, is also an introduction to the idea of polymorphism. In a very general sense, polymorphism is the idea that one object can take many forms or stand in for another type of object. Let's see how this is done in our example. To get the big picture, we need to take note of two things. First, the ghoul class was derived from the AB Spike class, and a ghoul object inherits all of the state and behavior of the AB Spike. We even said that the ghoul was also an AB Spike. This is commonly referred to as the is-a relationship. A ghoul is a AB Spike. Secondly, note that when we wrote the move method for the ghoul class, we called the move method from the AB Spike class using the keyword super. But how could we do this? Isn't the AB Spike move method written for AB Spike objects? It is, but because a ghoul is an AB Spike, it can also call that method. Polymorphism allows the ghoul to stand in as an AB Spike. In this case, while calling and executing the move method defined in the AB Spike class. In fact, as we will see in upcoming lessons in this module, a ghoul object can stand in for an AB Spike object anywhere an AB Spike object is expected. Why does this work? If you think about it, any method that references an AB Spike object will only rely on the state and behavior included in an AB Spike object. And all of that was inherited by the ghoul objects. Keep this concept in mind as you move on. We will introduce and highlight more examples to illustrate this key principle. This lesson motivated the need for subclasses and inheritance hierarchies in the design of Java programs. Now that you've completed this lesson, you should know the proper syntax for extending subclasses from existing superclasses to build an inheritance hierarchy. You should also recognize what polymorphism is and be able to write methods that override methods inherited from a superclass. Moreover, you should be able to apply your new understanding of super to situations where you need to access methods from superclasses. There's a self-assessment quiz that accompanies this lesson. I recommend investing some time to work through that quiz before moving on to the next lesson.